Number 7. So we'll do that first question from your homework tonight. I don't really know what that looks like outside of the fact that it's a parabola with a y-intercept of -5. But if I take this and try to write it in the shifted form that we're used to looking at for vertical and horizontal shifts, I can use completing the square to help me get there. So x squared plus 4x minus 5. This is our function of x. I'm going to go ahead and complete the square. So to complete the square, we're looking at just that ax squared plus bx part. So we're going to look at just this piece of it. I'm going to rewrite this equation so that it's x squared plus 4x plus something. That will complete that square. And then we'll minus that 5. If I add something here, is that going to change my function?
Yeah.
Yes. What can we add that does not change a function, though? 0. So how do I make this adding 0? If I add something here, we need to
Add to the other side.
either add it to the other side, or if I'm trying to keep it on the same side, we could subtract it somewhere else. So we're basically going to add disguised zeros today. And so to complete that square, we're still looking at that purple section, kind of the completing the square steps. This eventually will turn into a perfect square of some sort, okay, which again, we look at our b term and cut it in half, so it's going to be a positive 2, because 2 plus 2 is 4. So then we square that, so 2 times 2 is also 4. I'd have to add 4 there. If I add 4, I need to disguise it as a 0. So I'll subtract 4 out there. Now I've taken this completing the square piece, and we have got it into that horizontal shift. So now I have left and right shifting. I can combine my like terms on the outside there, and I'll get my vertical shifts. So now I have this function, and I know that it's been shifted left 2 units and down 9 units. So this becomes much easier for us to graph. So if we're looking at it graphically, I know that we've gone left 2 units, 1, 2, and down 9. 1, 2, 3, 4, 5, 9. So we've got this coordinate point down here that is going to be at -2, -9. Okay, there's one coordinate point. Good starting spot. Okay, next piece, we can now go ahead and solve for our x-intercepts based on what we did yesterday. So if I make my y value 0, we can go solve for the x-intercepts. So we'll add 9 across. We'll take the square root of both sides next. So we'll end up with plus or minus 3 equals x plus 2. And then we can subtract that 2 over, so x is going to equal -2 plus or minus 3. Okay? And so as we look, this is going to come back to that topic we were just thinking about where we have an axis of symmetry. Everything is going to be in relationship to -2 plus or minus some numbers. So we kind of get to see that there's this axis of symmetry that everything's going to be symmetrical around. So I know that x, or -2 plus 3 will put me at +1. So I have that point, 1, 0. And I know that -2 minus 3 puts us at -5. 1, 2, 3 further up. So we'll be at -5, 0. Now we've got 3 coordinate points. What's the other coordinate point that's really easy for us to find? The y-intercept when x is 0, right? So we found our zeros as far as when y is 0. So if we substitute 0 in for x, we see that our y-intercept is just -5, because 0 will wipe out the rest of that formula, right?
Yes.
So I can see that from this equation, -5 becomes my y-intercept. So we go 1, 2, 3, 4, 5. This point is going to be at 0, -5. And keeping that idea of axis of symmetry in mind, if I went 2 units this way and got to a -5, what could I do that way? The same thing, right? So if I go 2 units further from -2, we're going to end up here at -4. So we'll have -4, same height because it's symmetrical, -5. Now you have 5 coordinate points. That's a pretty good graph. And so you can just take this piece and fill in all that information we just came up with. And now you got a really good graph. Yep.
Can you complete the square with negative parabolas?
Yes, you can.
Yeah.
So let's take a look at something super complicated. I'll have a negative and a number out in front of it. Something like number 13 from your homework. So number 13 from your homework, I believe, is our f of x equals -2x squared. That is it plus 8x and -7 plus 7. Okay, so let's say that's my equation now. Things are going to get a little more complicated. I only want to complete the square if this lead coefficient is 1. So in order to do that, I need to divide by that -2. Or in other words, we could factor it out because I don't want to divide and just make it disappear. So we could factor out this -2. So -2 is going to come out front. And then everything else inside we'll be able to work with and do the completing the square steps we just did. So this will be x squared minus 4x minus 7/2. Okay, so I've just factored out that -2 from everything, and now I have something inside that I can work with completing the square. So I'm going to again look at my ax squared piece plus b, and we're going to keep that -2 out front. So -2. This will be an x squared minus 4x plus something minus that 7/2. And because we have to disguise this as a 0, we'll also subtract that same value. All inside that parenthesis still, okay, because we factored that -2 out. We know this is going to turn into something that has a perfect square, so it's x with something squared. In this case, half of our b value is -2. -2 times -2 is +4, so we're going to plus 4. And if I add 4 there, I have to subtract 4 here. And then when I combine like terms out here, -7/2 minus 4 more. If we want, we can think about -4 is the same as -8/2, right? So -7 minus 8 more. This will give us -15/2. All inside those parentheses still. Good so far? So we factored out that -2 early, and then did the exact same completing the square steps, where this is our completing the square pieces. And now we need to reapply that -2 so we get rid of those parentheses. So our final step here is going to bring this -2 to that term as well as the second term. So you'll end up with -2 times the quantity, x minus 2 squared. And then we're going to have -2 times -15/2, so this is plus 15. And then we're done. So now I know that coefficient up front is going to make it an upside down parabola. Scale factor of 2, so it's going to be skinnier. Shifted right 2 units and up 15. Okay. So now we can take that and help us start to graph things. So we're going to go 2 units to the right, 1, 2, and then up 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Okay, so we're going to be way up there. This will be at 2, 15. Again, just like we've been doing with completing the square, I can make this now set equal to 0. We'll plug in 0 for our y value. Subtract 15 over and divide by that -2. So I'll show all my steps real quick. Hold on. -15. Now we can divide by -2, so this becomes positive 15/2. Then we can take the square root of both sides. This becomes the square root of 7.5 equals x minus 2. Then we can add 2 to both sides, so x will equal 2 plus or minus the square root of 7.5, which is roughly 2.6. Okay, so you can type that in the calculator just to make sure you know where you're at. But we're going to, again, think about this idea where we have this axis of symmetry at 2, and everything's going to be plus or minus off of it. And we're going to add 2.6, which will send us out here towards 4.6. So this would be 4.6 comma 0. And then if I were to subtract it, we'd subtract those 2.6, that sends us over here to negative 0.6, so negative 0.6 comma 0. We got 3 points. What's the other one that's easier for us to find? Y-intercept is 7. Plug in 0 for our x value. That piece just disappears. So we're left with 7. So we can go up here, 1, 2, 3, 4, 5, 6, 7. Okay, so it's 0, comma 7. We'll have a coordinate point. What's going to be the other coordinate point that has the same height? Bree? Excellent. How'd you come up with that? Perfect. So since this axis is symmetry, I went 2 units towards the left. If I went 2 units right, I'd be at the same height. Excellent. Now I've got these 5 coordinate points. I can take this and make a pretty good sketch of our parabola. And now we have our graph. Okay? So this one's going to help you find the vertex with the shift method we've seen. The other route we're going to take a look at today is using the quadratic formula, basically, is what we're going to use to find our vertex and everything else. So, okay, so if we take a look at something like this. Bring it right here a little bit. Okay, so let's, first of all, we'll recall that our quadratic formula can be written as x equals negative b plus or minus the square root of b squared minus 4, b squared minus 4ac all over 2a. We can rewrite this because it's basically 2 fractions with a common denominator. So you can rewrite this as the idea of x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And now in this case, we start to see what we saw in that last group, where there's something here, plus or minus stuff. So this is going to become that axis of symmetry. Okay, so now I can think about this part of the equation as my vertical line of symmetry, that axis of symmetry. So if we apply this to number 21, I've got negative, so my axis of symmetry will be x equals negative b over 2a, which equals negative 2 over 2, or, well, we're too fast for it. Negative 2 over 2, which is just negative 1. So if I'm thinking about this graphically now, I know that everything is going to have symmetry on the vertical line x equals negative 1. Okay, so that's at negative 1, basically. How do I find the vertex then? Right there. So negative b over 2a is the vertex, like it's going to be on this axis, right? So that gave me the x value. How can I find the actual coordinate point, the true vertex?
Plug
Excellent. So we're going to plug this in. So we're going to get negative 1 squared plus 2 times negative 1 minus 6. And so we'll get positive 1 minus 8. So we see that our y value when we plug that back in is going to be negative 7. So we see our vertex is the coordinate point then. So there's 1, 4, 5, 6, 7. So we're at the coordinate point negative 1, negative 7. Okay. Now you have the vertex. This is really nice, and we'll use this again tomorrow, because it finds you your max or minimum like that. No matter what this equation is, you just plug in x equals negative b over 2a, and now you can substitute that back in to figure out what the true vertex is, and we know the minimum is at negative 1, negative 7. Same things are going to apply now. We got to find the x and y intercepts, basically. Y-intercept is going to be negative 6. That one's still pretty easy for us to find. So at negative 6, 0, negative 6, we've got that. Using our axis of symmetry, what's the other coordinate point I know? What is the page? Negative 2, negative 6. Good. Okay. So I went over 1 unit this way, so if I go 1 the other direction, I'll be able to find that coordinate point at negative 2, negative 6. And then you're already using the quadratic formula, so to find your x-intercepts, just finish off the rest of the quadratic formula. So our 2 x-intercepts will become x equals, you've already done this first piece, so you don't have to worry about doing the math on that again. Just plug that piece in, so negative 1, and then plus or minus this piece, and plug your stuff back in. So our b is 2, so we're going to end up with a square root of 2 squared minus 4. A is 1, c is negative 6, all over 2a. And so we'll end up with negative 1 plus or minus the square root of 28. So that'll be 4 plus 24. Square root of 28 all over 2. If you want to simplify that radical, hopefully you recognize that that's the same as 2 radical 7. And so the 2's would cancel top and bottom. This is where simplifying radicals can sometimes come in handy. So this will end up being 1 plus or minus radical 7. If you don't get to that point, that's okay. Just keep that piece and type it in your calculator. You should be able to figure out both those. So radical 7 is like 2 point something, 2.6, 2.7 or something like that. And so we can go to our axis of symmetry. We'll go 1, 2.6, something over there.
Yeah.
So we end up with 1.6, comma 0. And the other direction, if I subtracted 2.6 more, we'd end up at negative 3.6. Comma 0. And now you have your 5 coordinate points. Go ahead, connect the dots. Okay, so we got those graphs.
You just use the calculator.
Questions, comments, concerns on how to do this by hand? Feeling okay? So some of it will be completing the squares, some of it will be using the quadratic formula.
If there's no why do we need the 2 points that are